Good day everyone. So today we'll be discussing about radar plotting, and this presentation is prepared by the following cadets: the cadet Gentallan, the cadet Gocotano, the cadet Ilustrisimo, and the cadet Paborada. So without further ado, let's um, discuss the course outcome of this presentation. So the first course outcome is to refresh and develop a better understanding on the manual radar plotting. The second course outcome is to effectively apply the correct steps on radar plotting. And the last course outcome for this presentation is to apply the importance of radar plotting to collision avoidance. And the next slide is the learning outcome. So on completion of this presentation, we should be able to, number one, demonstrate a proper step-by-step process of manual radar plotting. Number two is to determine new terminologies used in manual radar plotting. And the third one is we would be able to apply radar plotting to collision avoidance in the sea. So the importance of this topic is with ARPA on board ships, the art of radar plotting is fading away, as we all know. But it is not that radar plotting is not relevant nowadays. In situations like sailing with inoperational ARPA, under flag dispensation, radar plotting will be of a great help, and thus this is very important topic to discuss with, which will help us eventually in desperate situation that we are required to do so. So, um, the introduction of this presentation will be discussed by Decadent Gocotano. So, take it away.
The USCG requires that radar observer certification be renewed every 5 years. Since modern electronics are so agile, many mariners have not done actual radar plot in those 5-year intervals. To brush up for the brush, here is a quick refresher on radar plotting procedure. So the United States Coast Guard produces a new certification must be renewed every 5 years since the electronics are so agile, so it has been renewed quickly because it will be changed time to time. We'll begin with a vector triangle, as is the case with all triangles. This one has 3 sides. Number 1, side E to R represents the true course, direction, and speed length of ER, vessel, VR, ER. So, as you can see in the illustration, that the red line, that the middle is the E to R is the direction. Next is the side EM, represents the true course and speed of the other them. Them is the EM vessel. Next is the side RM, represents the relative motion vector, the direction and the speed of other vessels' apparent movement. Letter E is anchored in the plot. M, may, and R certainly will be relocated, but E doesn't move.
Terminology: CPE, or closest point of approach. If the line of relative motion to extended, the CPE is the shortest distance from that line to the center of the plotting sheet, where our own ship is located. If the CPE, or closest points of approach, we are on collision course with the other vessel, so RML, or relative motion. Relative motion is the line is called direction of relative motion, or DRM. If both the target vessel and your vessel maintain the same course and speed, the target will plot right down this line. If the line passes through the center of the sheet where your vessel is located, there will be collision. In RML, or new relative motion line. RML or relative motion line, in RML, new relative motion line, speed of relative motion, length of relative motion, direction of relative motion, the position of the other ship on RML at planned time of evasive action point of execution. SRM or speed of relative motion. We can define relative speed as the speed of moving body with respect to another. When two bodies are moving in the same direction, the relative speed is computed by their difference, but when the bodies are moving in the opposite direction, the relative speed is calculated by adding the speed of both the bodies. DRM, direction of relative motion. So, the relative motion velocity refers to an object which is relative to some other object that might be stationary, moving with the same velocity, or moving slowly, moving with higher velocity, or moving in the opposite direction. So MX or the position of the other ship on RML at planned time of evasive action point of execution. That's all.
Hi, I'm Cadet Paborada. For today, I will tackle the radar plotting. Radar plotting used to be referred to as rapid radar plotting, which emphasize ko niya is rapid in order to make the procedure quick and mathematically painless. Contacts are usually observed at interval of 6 minutes. Kada 6 yun na siya interval daw. Then 12 minutes or 15 minutes. Then calculating the speed o distance niya kay para sayon, muna yung mga example niya. Kung ang vessel kuno kay nagbiyahe og 18.2 knots, muna siya kuno ang 8.2 nautical miles per hour kada sa kuan oras. Then kung kuan siya, mo travel siya 1 out of 10 na speed na 1.82 miles, and 6 minutes kay ang 1 out of 10 nga hour. Then second nga example niya is kung ang vessel kay may travel og 1.2 miles in 6 minutes, ang iyang gikos gon kay 10 times daw, then 12 knots. Will work as standard 6-minute plot step by step. Your ship, ang course sa ship kay 345 degrees, then ang speed niya is 15.0 knots. So kinang lang imong bantayan nga mo follow ka sa radar contact. Na ay upat ka kuan kanang mga following radar contact, which is una is what will be the CPE, then una imong panon, then kuhaon, and sunod is what is the contact's relative bearing, then what is the contact's true speed, then ang ika-upat lastly is when the range to the contact drops to 4.5 miles, you want to change course, then contact passing you on the port side with a new CP of 2 miles. Then what is your ship's new course? Thank you.
So here is the step-by-step process on how to properly execute manual radar plotting. So step number 1, notice that the plot is a 6-minute plot. So speed, distances, and time will be based on a factor of 1/10. So using a maneuvering board or radar transfer plotting sheet, draw a line from the center, that's our ship, in the direction the vessel is heading. So this represents the heading flasher. In this case, our course is 345 degree. So step number 2, plot the first contact using 1:1 scale at a bearing of 329 degree and range of 9 miles, and label it with a small letter R. So in this step, we are now plotting the first location of the observed contact. So this contact, we had observed at 0830 hours at a bearing of 329 degree and range of 9 miles. So we will be plotting it in the maneuvering board and label it with a small letter R, representing the first observed location of the contact. Step number 3 is to locate E on the plot, which is the reference of our ship. So set dividers for the distance our vessel will travel in the interval of the plot. In this case, we have 6 minutes at a speed of 15 knots, which is 1.5 miles. So parallel the course line 355 degree, which is our vessel's heading, over to R, and draw it in backwards away from R. So this represents our E. Label it with E. This position is labeled as a small letter E, representing the reference of our ship. So remember, the course is from E to R. Step number 4 is to locate M, which is bearing 326 degree at a range of 6.0 miles at 0836 hours. So this is the second observed location of our contact. After 6 minutes from the first observed location of our contact, the contact had reached a range of 6.0 miles at 326 degrees. So we will be plotting it in the maneuvering board. Now it is possible to finish the triangle and solve for the other vessel's course and speed by connecting E to M, which results to approximately the other vessel's course of 146 degree and a speed of 16 knots.
Step 5. Draw a line from R through M and past the center of the maneuvering board or the move board. This is the line of relative motion, or the RML. The vessel to the closest point, or CPA, on the RML is the CPA, or the closest point of approach. In this case, the CPA is about 1 mile. Measure the length of R to M to find the contact's relative speed. Here it is approximately 30 knots. So to find the contact relative is you have to measure the length of the ship, of the contact or the target, which is the R to M. Step 6. According to the problem, when the range to the contact drops to 4.5, we are to change course so that the contact will pass on our port side with the CPA of 2 miles. The next step then is to mark on the RML, or the relative motion line, the point at which the contact reaches a range of 4.5 miles from us at the center. Label this point MX. From MX, draw a line tangent to touching the 2-mile circle. When we change course, this will be the NRML, new line of relative motion. So if there is the contact, then you have to change course to the port side in order for you to avoid a distress.